All right, folks, welcome to 6.5, graphing tangent, cotangent, cosecant, and secant. We really want to focus on all four of these functions, and we're just going to go ahead and get right into it. So there's a lot of asymptotes involved today, just kind of FYI, and looking at these things as being reciprocal functions and what that represents. So we're going to start off with tangent. And tangent and cotangent both have periods of pi, not 2 pi like sine and cosine. These are our only two functions actually that have a period of pi, and you'll see why in a few moments. We get these functions, the big function here, f of x being a times the tangent of bx plus c plus d. Now, this is exactly as we had for sine and cosine, and it's basically going to be the exact same thing we have for cosine and cosecant and secant. But you need to understand what the a, b, and c, and d all do basically the same thing they did in sine and cosine, with the big difference that since the period is pi, in order to find the period, we do pi over b, not 2 pi over b. Make sure this is in there somewhere on your notes. This is only for tangent and cotangent. So let's take a look at tangent of x. I'm going to draw some axes here. And we got to figure out what we're going to do with those axes. So let's try to take a look at some values on our table, kind of like we did with sine and cosine. We have, let's just try the same ones we did before. Oops. Now, if we did the tangent of 0, and you can just go to your unit circle and figure out that the tangent of 0 is 0. That's nice. Tangent of pi halves. Well, tangent of pi halves is undefined. Tangent of pi is, well, that's 0 again. Sorry, this is supposed to be 3 pi halves. I don't know why I deleted that earlier. Tangent of 3 pi halves, oh, that's undefined again. And the tangent of 2 pi is 0 again. Well, that's not very interesting now, is it? If I did, let's go pi halves, pi, 3 pi halves, and 2 pi. And we go in the other direction as well, just to kind of keep this symmetric here. Okay, so now we got to figure out what's going on here. So we do have a point at 0, 0. That's good. But what happens at pi? Pi is undefined. Well, what do we put at undefined? I hope everybody out there says, oh, it's an asymptote, and it is. So we have to put an asymptote here at pi halves. Well, at pi, it's 0. And 3 pi halves, it's an asymptote again. And 2 pi, it's 0. Well, that doesn't really show me anything of what's going on. So let's think about going backwards. If I did the tangent of negative pi halves, well, I would get another asymptote there, undefined. If I did the tangent of negative pi, I would get 0 again. And then negative 3 pi halves, I'd get an asymptote again. And at 2 pi, I'd get 0 again. Dang, well, this doesn't really show me any lines that are going on. All it shows me is dots and some asymptotes. So what we need to do is we need to figure out what's going on between the asymptotes here. And what I want to point out here is this distance between two asymptotes is one full period. From negative pi halves to positive pi halves, that's 1 pi. So what I want to do is I want to think about, oh, let's change my table to go from negative pi halves with a 0 and a pi halves. And then we want the middle things. And the middle things are going to be negative pi fourths and pi fourths. So the negative pi halves we get undefined. The pi halves we get undefined. 0 we get 0. And a negative pi fourths we get negative 1. And a positive pi fourths we get a positive 1. Well, that helps because now this little dash that I'm putting in here are the quarters, the pi fourths. Well, that means I need a 1 and a negative 1. And then some of you are going to think, oh, it looks like a straight line. Well, it does kind of. However, if you were to try to do smaller and smaller values, and obviously we have to approach this asymptote, this actually ends up looking like, as best as I can draw it, kind of like a cubic function. And this pattern continues in between every set of asymptotes. So graph this on Desmos, see what it looks like. I don't have Desmos up. But you should get a whole bunch of these squiggle lines, these cubic-looking functions. And what I'm going to continually point out is the distance between every two asymptotes is one full period. So what I have drawn here, without this piece and this piece at the ends, this is 3 full periods of this graph. Now what I want to point out is this 1 right here has to do with the A. My A was 1, so I went up to 1 and down to negative 1. My period was pi, and it's centered on the y-axis. So let's look at a slightly more complex version. Let's look at let's look at 2 tangent of, let's go 2x, might as well. So here's what I need to figure out. Amplitude is 2. Period is pi over b, so it's pi halves. Now because I don't go left, right, up, or down at all, I know tangent is going to start at 0, 0. And it's going to go up to 2 and down to negative 2. The thing is now I need to figure out my asymptotes. Well, for tangent, from this center line, you need to go in this direction a period over 2. So you need to go half of your period to the right and half of your period to the left of this point. Well, that's pretty simple, I think. Half of my period. So my period is pi halves. Half of that is pi fourths. And half of that is negative pi fourths. So notice the distance between these two numbers is 1 full period of pi halves. This is where your 2 asymptotes are going to come in. And you can verify for this for yourself. If you plugged in negative pi fourths into this, you'd get the tangent of pi halves, or negative pi halves, which is undefined. And likewise here. Which means I also need my quarters here so I know where the up and the down go. Since this is a positive tangent, I'm going to go up to 2, and I'm going to go down to 2 in this fashion. And the best that I can draw here, I'm not very good at these on this. This is really ugly. And I get something a little bit like that. Try something a little bit more challenging. Let's say it is the tangent of x minus pi fourths. So what we need to do is normally tangent starts at the 0, 0, but I need to go right pi fourths. Oh, I didn't pick out any of this stuff. Amplitude is 1. Period is pi over b, which is just pi. All right. And then my phase shift is pi fourths over 1, c over b, which is just pi fourths. And it is to the right. So this dash here represents pi fourths. Since my period is pi, I need to go half of that distance to the right and half of that distance to the left. So I need to go this direction, pi halves. So this is 3 pi fourths. And I need to go this direction, pi halves, which is negative pi fourths. That means the full distance across is now 1 pi, which is what my period is. These are your asymptotes. Oops. Your middle is your intercept. And your other two middles are your min, or not your min, but your other two guiding points. And there you go. You don't need these arrows across the top that I have here. I'm just trying to stress that from the center we go half of your period to the left and half of your period to the right, and to show that the two asymptotes are 1 full period away. Okay, let's move to cotangent. It's kind of the same thing, just looks a little bit different. So cotangent is going to do this. So I say, okay, x and y. If I wanted to make a table like I did for tangent, let's start with 0 here, and let's go pi fourths and pi halves and 3 pi fourths and oops and pi. Cotangent of 0 now is undefined. Pi fourths is 1. Pi halves is undefined, and 3 pi fourths is sorry, not undefined, 0. My fault. Cotangent of 3 pi fourths is, well, I guess those aren't the same values, but these are the values I wanted to use anyway. -1 and undefined. So notice 1 full period goes between 0 and pi now. So at 0, we get the undefined vertical asymptote. And at pi, we get the vertical undefined asymptote. And then at 0, 0, or pi halves, comma 0. And notice the difference here for cotangent. It starts up and goes down in this fashion. So it's a downward cubic rather than an upward cubic. It's kind of ugly. So notice the distance between these two asymptotes is 1 full period, which is pi in this case. And notice from pi halves, it's half a period to the right, half a period to the left. So let's try some more complex. And by the way, these are the first two graphs that I did. This one is the parent function for cotangent. The other one's the parent function for tangent, obviously. Let's try 2 cotangent of, well, let's just go 2x. So my amp is 2. Period is pi over b. So it's just pi halves. Okay, because I did not shift left or right, I automatically have an asymptote at the y-axis. Then my next asymptote comes 1 full period away, and 1 full period is pi halves. And then I cut that in half, and then half again, just like we did for sine and cosine. Cotangent in the middle here is going to be my 0. And because it's a positive version, it's going to be a downward slide. So I got to go up to 2, down to negative 2. And as best as you can, that was kind of an ugly one. I should kind of come down here like that. And look like a negative cubic. So let's do a little bit of a shift. Let's go left or right here. Let's go ahead and go to the left. So let's say cotangent of x minus pi fourths. Let's go left, so let's go plus. Now this works a little bit different. Still the amp is, 1, not 2. Period is pi over 1, which is just pi, and a phase shift of pi fourths over 1, which is pi fourths. Good. All right, so this is also pi fourths to the left. So here's what needs to happen. I need to go pi fourths to the left. Now, what this does is it moves my vertical asymptote pi fourths to the left. My next asymptote has to be pi units away. So let's go 1 pi fourth, 2 pi fourths, 3 pi fourths, 4 pi fourths. So this is, over here, it's not 4 pi fourths, it's actually 3 pi fourths. That distance is now 1 full pi, which is where my second asymptote goes. I get a dot, and a dot. And let's see if I can do this a little bit better here. Nope, not really. Nope, not really. Man, I missed. I hope you get the idea for that tangent, cotangent. Okay, takes practice. Don't stress over whether or not you get it right away. All right, let's go to cosecant and secant. As I mentioned to the classes today, if you can graph sine and cosine, you already have the necessary fundamentals for cosecant and secant. For both of these, they have the same periods as sine and cosine. So you still do the 2 pi over b. Like I mentioned, tangent and cotangent, the only ones with pi over b. In order to graph cosecant of 3x minus pi, we would use sine of 3x minus pi as an outline in order to graph. So for example, cosecant is the reciprocal of sine. So cosecant of x is 1 over sine of x. So if sine of x is 0, cosecant of x is undefined, which means that creates an asymptote. And the last two here is if there is a maximum for sine, it becomes a minimum for cosecant, and a minimum for sine becomes a maximum for cosecant. And this goes along the same lines. You could replace this stuff with secant and cosine, and you could replace all the sines with cosines and all the cosecants with secants. Same idea. But what I want to do is I want to graph something here. Let's look at the parent function for secant x. And I'm basically going to say, oh, this is like cosine of x. Okay. So the parent function for cosine of x is going to do this. 2 pi, pi, and my halves. It's going to go up to 1, down to negative 1. Now cosine looks like this. I'm going to do this in blue here. Cosine starts here, goes to the middle, minimum, middle, and maximum. Now, you could draw in the cosine curve if you wanted to. I sometimes do with a dashed line because it's not really there. It's not part of your graph. It's just a guide. But what I do want to do is I want to actually graph in secant. So as I mentioned before, every time the function crosses the x-axis or the center line, there's an asymptote because 1 over 0 becomes undefined. So here I get 2 asymptotes. This maximum for cosine becomes a minimum for secant. This minimum becomes a maximum for secant. You have to follow your asymptotes because that's the whole idea of an asymptote. And this maximum becomes a minimum. And that is 1 full period of secant between 0 and 2 pi. If you were to continue to the left, if you wanted to here, this would be negative pi halves, which for cosine would be 0, but for secant is undefined. And it comes up here like this. And obviously this would come up here like this. And you would just keep repeating these upwards and downwards. They're almost parabolas, but not really. Okay, and it just continues forever. All right, so if you wanted to do something like secant of x minus pi halves, I would think cosine of x minus pi halves and graph that. So let's call that pi halves, pi, 3 pi halves, 2 pi, and 3, 4, 5, 5 pi halves. And then I would go like this, cosine, and you could do all of the little things here. I'm just going to kind of speed through this a little bit. This moves me right pi halves units. Cosine's going to start up at pi halves to the right. It's going to go middle. It's going to go down, middle, up. I'm not going to graph cosine because I don't really care about cosine. I'm going to graph whatever secant was. So secant has an asymptote here and here. And technically here again. So you can use that. And you can use that. And we get the somewhat parabolic curves. All right, so that's secant. Cosecant works exactly the same. So if I was to say, hey, let's graph the cosecant of x, let's just look first at the parent function. I would think sine of x looks like this. I'm going to go to pi halves, pi, 3 pi halves, and 2 pi, up to 1 and down to -1. Sine looks like this. Goes to the 0, goes up, 0, down, 0. I'm not going to draw sine because that's kind of pointless. It's not necessary. I just need to use those dots. So it crossed the middle line there. We have an asymptote. It crosses the middle there, so we have an asymptote. And it crosses the middle there, and it has an asymptote. Maximum becomes a minimum. minimum becomes a maximum. And there you go. That's one full period of cosecant. Okay, so this is the basics on how to graph these 4 new functions. But notice, I think they're actually a little easier than your initial learning of sine and cosine. Whenever you see secant and cosecant, always think of the reciprocal friends, sine and cosine, and do basically exactly as I have. All right, find your amplitude, find your period, find all that, then set up your axes and go from there. All right, I'm always here to help. I will see you guys tomorrow.